Hello, how you doing? It's MrDoTheMath here, and today we are going to talk about segment bisectors, midpoint, and distance formula. So we got a bit to cover. All right. So, like I said, we just drew a segment here, right? And the segment, when we folded it in half, it created a line, right? We had AB here, and this line created that intersection made M. And when we measured it, we noticed that both of these were equal to each other. All right? Because those are equal to each other, this line here is called a bisector. A bisector. All right? So, when something bisects something, it cuts it in half. When it cuts it in half, that means it creates two equal parts, right? So to bisect, it means to cut in half are two equal parts. All right, two equal parts. Cut in half are two equal parts, right? That's what bisect is all about, okay? The other thing, so what's fantastic about this bisector is the bisector, again, it cuts it in half or it creates two equal points. It's also known as a midpoint. Midpoint. Midpoint is the bisector, or it's the place in the middle. Alright? So midpoint is just what it is, the middle point. The middle point. Alright? So what in essence happens is anytime that you have a bisector, anytime they use the word, in geometry they're going to use bisector. They ain't going to say something was cut in half. They're going to say this line is a bisector, this point is a bisector, this ray is a bisector. So with that being said, a bisector can be a point. I think it says that in your slide, right? It says a bisector can be a point, a segment. It can be a point, a segment, a ray, or a plane, right? That intersects at a midpoint. So this right here is your bisector. This is your bisector because it cut it in half. That was your fold, right? It cut it in half. And the place where it's cut in half is your midpoint. That's your midpoint. All right, bisector and midpoint are very, very well related. All right, they could be brothers if you wanted to do them that way. Okay, so let's look at some applications. Let's look at example 1. All right, we have this. We'll call it parallelogram for now. It's parallelogram where you have S and A here. And then across here, so this you got line SA there, and then you got RM. Alright? RM intersects SA at X. Okay? And so, they said RM is a bisector. Since RM is a bisector, RM, then SX and XA are related in what way? They're congruent. Good. They are congruent. So they're equal to each other. Okay? Now the next about information says that SX equals 25.5 degrees. Right? So based on this picture already, because this is a bisector, that means that SX is congruent to segment XA. We all good with that? Everybody good with that?
Yes.
Mm-hmm. Alright? So they want to know what SA is going to be, okay? In order to figure out what SA is, we can use the segment addition postulate, right, from yesterday. So we would add SX plus XA together to get SA, okay? And so, because SX is 25.5, XA is also 25.5. Therefore, what's the measure of SA? Yeah, 51. You add those together. Okay? We good so far?
Yes, sir.
Okay. Again, a bisector cuts it in half. They said he was a bisector, which meant that these two created equal sides, created equal segments. All right? They gave you the measure of one of those segments. All right? With the measure of that segment, you were able to figure out everything else. All right? You were able to figure out everything else. Alright, so that's the basic skill, right? If this is 25.5, then this is 25.5, right? Alright, now let's make it more complicated. Okay? Let's look at the next slide where we have a segment. We have this segment. Bam, bam. And they said BMW. Alright? Said M is the midpoint. What's midpoint mean? Middle, right? And they said VM is 4x minus 1. And they said MW is 3x plus 3. Alright? They want to know what VM is. Alright? Because M is the midpoint, both segments are equal. Okay? So, because both segments are equal, we can write this this expression or this as an equation. Right? We can say 4x minus 1 equals 3x plus 3. Because again, we already said VM is equal to MW. Right? Since they're equal, we can set them equal to each other. Okay? From there, we solve for x. We solve for x to figure out what x is to go and figure this out. So the first thing we want to do is we need to move some stuff. So what do you want to move?
3x.
You want to move to 3x? All right, so it's positive. So you got to subtract 3x from both sides, right? We good so far?
-1.
So we subtract it. All right, so we end up with x minus 1 equals 3. Then plus who?
Plus 1.
Plus 1, right? Alright, so you add. So x equals what?
4.
X equals 4, right? We're not done though. But wait, there's more. Because we got to find VM. So now we know what x is. VM equals 4x minus 1. We know what x is. So we
So plug
substitute.
it in.
So 4 times 4 minus 1. Therefore, VM is what? 15. 15 units. 15 units, whatever it is. Alright? So now we've figured out what VM is. We okay? Alright, so the first thing we have to do is we have to solve for x. Because this is a midpoint, these are equal. Okay? Which is how we got this formula, this equation. We solve for x, and then we substituted x into this expression. So, check this out. If VM is 15, how long is MW?
15.
And how long is VW?
15. Or 30. VW is 30.
30. Right. It's 30. Okay? Cool. So, any questions so far? How we feel?
Good.
We good? Okay. Let us look at let's look at a messy one, right? A lot of times we get clean problems like this. We get a solid 4 and a solid 15, and we know that we must have done it right? But what happens if we have a fraction, right? You have to trust that your fraction is correct, okay? You have to trust that your fraction is correct. So let's not look at A. A is like, in example 3, A is like really fuzzy. Let's look at B. Let's look at B. All right, so can you see B? All right, so B says we got this segment here, PQ, and we have this. What's this gonna be called?
Bisector.
Good, it's a bisector. Right, it's a bisector, and it's M. These markings right here tell us what?
They're congruent.
They are congruent, very good. So we got 5x minus 7 here, 11 minus 2x. Okay? Now, they want to know what PQ is. We have to figure out what PQ is. In order to figure out PQ, the first thing we need to do is figure out. Yeah, we gotta solve for x. So let's set them equal to each other because Molly said that they're equal. Okay? Alright, what do you want to do first?
You want to check it right?
Do what to 7?
Plus.
Add 7 to both sides. Okay? So you'll have 5x equals add 7 to both sides. So you got 18 minus 2x. Then what?
Subtract 2x.
Add 2x.
Let me add 2x.
You add or subtracting?
Add.
Why?
Because it's negative sign.
Okay.
Right.
Good. So now we got 7x equals 18. Then from here?
Divide by 7.
Divide by 7.
Divide 7.
18 over 7.
Alright, we got a question?
No, we do not.
What's the question? Let's hear it. You good with this? You want to convert this?
No, I said you want us to convert it.
Do I want you to convert it?
Do it like that.
Do we need to convert it? Let's see. Do you want to convert it? We can mean. It's going. So, but we got to get this to be PQ. So it's finna get real messy. But hey, you can leave it like this if you want to. It's okay. It's gonna be weird though. Here we go. So 18 over 7. 18 over 7 goes in this place here.
Yes.
So we're gonna have 5 times 18 over 7 minus 7, right? Which is gonna be, you do 5 times 18. 5 times 18 is what?
5 times
90.
18.
So 90. 90 over 7 minus 7, right? And then 90 divided by 7. Or do you want? So then we can do it like times, right? So it'll be 90 over 7 minus 49 over 7. Does everybody see where that came from?
Yeah.
Yes.
Yeah, because it's a 7 over 1.
Yeah.
Had to get common denominators. Okay? So subtract 90 from 49. Help me out.
59.
It's 51?
Oh yeah, you right.
Yeah.
Oh yeah.
Yeah, 41. 41.
41 over 7. Okay? 41 over 7 is going to be PM. So you're going to add another 41 over 7 to get the whole thing. So we can say like 82 over 7. Right? No, don't short me. It's like, so both of them are 41 over 7, right?
Yeah.
Right. You got it. Yeah.
Yeah.
They're congruent.
Yes.
This is 41 over 7.
And this is 41 over 7, and that equals 82 over 7.
Pretty much, when they're like that, you just need to find one. Okay? We all good?
Correct.
Alright, so, awesome sauce. So, we've dealt with segment bisectors. These are segment bisectors. The bisector cuts it in half. The midpoint is the place where that half is happening, right? Now, let's look at the midpoint formula, right? Midpoint formula is dealing with midpoint, and distance is dealing with coordinates. What are coordinates? We talked about that yesterday. What are coordinates? A point, a place, a location, right?
Hey.
Alright. Midpoint. Midpoint. There is a formula for it. Midpoint is going to be the middle of a line in a coordinate plane. Alright? We did.
Yeah.
I don't think we talked. Did we talk about this?
Yeah. We kind of did.
So like this is the x-axis, this is the y-axis, right? Yes. We have 4 quadrants. First quadrant, second quadrant, third quadrant, and yeah, because me and Oscar talked about it in the back. I mean, not Oscar, and Marion. Right? So, anyway, when they give you a point here, they give you 2 points, we can create a line. Alright? If you want to know where the middle of the line is, you use the midpoint formula. The midpoint formula is going to be basically the average of the 2 points, right? For x and for y, right? A coordinate is always in x and y. So for the midpoint formula, it's going to be the average of x1 plus x2 over 2 and y1 plus y2 over 2. Okay? x1 and y1 represent the first coordinate, right? And x2, y2 is the second coordinate.
Right.
Alright? We all good where these come from?
Yeah.
Okay? So, I don't want to say it like this, but so what you do is, when they give you 2 coordinates, you substitute the values in here, and then you simplify and you have your midpoint. Okay? So let's look at the example on the in your paper. So, AB, the endpoints of AB are A is 1, 2. So A is 1, 2, and B is 7, 8. B is 7, 8. Okay? So if you look at this, if we struggle with identifying x1 and x2, label it. So that's x1 and that's y1. Okay? And then on the bottom one, let's label this x2 and y2. Okay? So now we've identified who's who and what's what. Okay? From there, substitute it into the formula. So x1 is 1. x2 is
7.
7 over 2, right? That's the first one. And then for y, y1 is 2, and y2 is
8.
Ojo. Alright? Okay? So the first thing you want to do is like label your x's and your y's. Your x's and your y's. And then from here, you want to substitute. Substitute your value in, right? And then finally simplify. Alright, so right here, 1 plus 7,
8.
8 over 2, and then 2 plus 8,
10.
10 over 2. That gives you an order pair of what?
4. I'm a 5.
That is the midpoint. That's MP. That is your midpoint. Okay? You take your values and you substitute it in. Okay? What if they give you the midpoint value and you have to find an endpoint value?
What do you multiply? Like 4? Yeah. To go reverse.
Do one of those things, right? So let's look at the problem here. So it's important that you read what they're saying. So in this particular situation, they said the midpoint MP equals -1, -2, right? And they said one of the endpoints W is 4, 4. Alright, so just like this problem that gives you a midpoint, to help you find an endpoint, what you would do is basically you'll set up a problem. So this is what you'll do. You set up an equation.
Midpoint.
So you take the midpoint of x, set it equal to x1 plus x2 over 2, and you solve, right? And then you do the same thing for the midpoint of y. That's how you find your endpoint. So you do y1 plus y2 over 2. Okay? Now there's several ways you can do it, but this is the way I'm thinking about it when I do it. So we got a midpoint, right? And we have one endpoint. We're trying to find the other one. So let's substitute these in. So we got the endpoint x, which is -1, equals, right? We substitute. Equals x1, 4, plus x2, we don't know, over 2. We all good with that? Okay, now we have an algebra problem. Okay, and we're going to get rid of this denominator. So we're going to multiply 2 to both sides. Right, so we don't have it over here, times 2. So now we have -2 equals 4 plus x2. We all good so far? No? What happened? Okay. Alright, again. I'm gonna rewrite it, it's all good. So, this is that, right? This is that. Alright, I don't think she's following. This is that. And so we have to we'll move the 2 over first. Alright? So we move the 2 over, we gotta multiply 2 to both sides. Times 2, right? There's a 2 at the top, 2 at the bottom. There are no 2's over here anymore. 2 times -1,
-2.
-2 equals 4 plus x2. Okay? 4 plus x2. And then we solve for x. So we gotta move this forward.
Oh, I can't understand now.
What do you do? Where I get the -1? It's the given midpoint.
So it'd be
It's given.
-6.
All of this up here is given. They gave you the midpoint and they gave you an endpoint. We're trying to find the other endpoint.
Oh, okay.
Okay? So subtract 4 to both sides. X is going to equal -6. So that's the x value. Alright? we got to do the same thing with the y. Okay? So the y midpoint is -2. Okay? David, we good? Because she not paying attention. Are we good?
I don't even know what you're talking about.
Equals
It's on there.
4
I got it down.
plus y2, right? Over 2. And we do the same thing all over again. Get rid of this 2. Multiply 2 to both sides. 2 times -2. -4 equals 4 plus y2.
Mm-hmm. Should be -8 equals y squared.
You okay? Give me a head now. Let me know
Yeah.
you're okay. Yeah? Alright. Subtract 4 to both sides, so then y equals -8. Okay? So now, your endpoint is going to be -6, -8.
Yeah.
Okay? It seemed like a long time because I was working it out and waiting and working it out and waiting. Alright, yes sir.
For like the y2 and the x2 on these problems, why it just automatically go to y?
Why is it y and x?
Yeah, right there.
This one?
Yeah. Like why does it automatically go to y?
Because we used the y value. Does that make sense?
Not
Look,
for
we did it twice. We had to do it twice. We did it for x and we did it for y. We had to work it out for x and for y. So we used the x midpoint and we set the problem equal to the x midpoint, and then we set the problem equal to the y midpoint. Okay? And ironically, we had the same number for x and y on the other endpoint. Okay? But what's most important is this formula here. Right? If you're given a midpoint and you're trying to find anything here, you need to work it out that way. So, are we okay? This is midpoint. Yes, sir.
So both of them are just kind of like, so you're trying to find x and y only on the first coordinate, only for -1.
Like one of these?
On top where it's negative, or you're trying to find both of them, just x and y on that same.
Well, yeah, you got to use that to find. So this is the midpoint. This is the endpoint. You're trying to find the other endpoint. Okay? So basically, you have this going on. This is W. This is the midpoint. We have to figure out where that is. And in order to figure out this coordinate, we need to find the x value and the y value. Okay? We have to find the x value and the y value. Okay? Looking at this, is there a simpler way to write out midpoint? Like this part. Is there a simpler way to do this? No. No? Is there a way to set it equal to y? Set this equal to y?
What?
Oh wait, I just figured it out.
Yeah? Okay. Does everybody see that? So what you could do is we could, like, if we was trying to find solve for its x, right?
Mm-hmm.
We multiplied 2 and we subtracted this, right?
Yeah.
So what if we set it up like this?
Subtract that then.
For both of these, it'll be like 2 times the midpoint, x or y, minus an x or a y gives you the missing x.
Yeah.
Right?
Right.
And then the same way for the y. So it's 2 times the midpoint
Y.
of y minus y given
Y
equals
squared.
y2. Huh?
Or Y2 here.
I just did this right here. So then all you got to do is substitute stuff in. So all I had to do now is like I substitute the -1 in, substitute the 4 in, and then you find that. All right. So this is that, just a little simplified. Okay. So you can this'll take steps away from you. Like this will make you work it out faster. You can work it out faster this way, or you can start here. Yes, sir.
So, like on the first one where you did -1 equals 4, so would you put x2, and on the other one you put y2, like.
Yeah.
You do that every time when you try to find that.
Well, I just use the 2 because, well, it doesn't necessarily matter because this is the only given one, right? So you can identify this as x2 and y2, and you find the x1 and y1, if that's what you're talking about, right? But yeah, so that's what's going on right here. Yes, ma'am.
So like the first one, the negative one came from the midpoint.
Yes.
And it's the x and then the y here.
Yes, ma'am.
Okay.
Cool. We all good?
Yeah.
All right, what's up with it? All right, we'll cut it out here and then we'll talk about distance formula for a moment. Don't forget to like and subscribe. Mr. Do the Math out.